Hello everyone and welcome to my latest Rust Quickie. In my previous Rust Quickie I have talked about the various integer data types that Rust supports, and today I want to continue that discussion by talking about the floating point data types, the character data type and the boolean data type that Rust supports. So let's switch over to Visual Studio Code where I want to show you those data types in more detail. Let's start by talking about the single precision data type that Rust supports. As you can see, that data type is called F32, and I'm defining here two variables. The first variable has a value of 1.0, the second variable b has a value of 5.0, and I'm using here the suffix F32. And then we are doing here a few point line markers. As you can see, we can print out the range of the F32 data type by using the constants min and max of that data type. So let's have a look on those. Let's go to the definition. So you see here the definition of the minimum value, and you have here also the definition of the maximum value and a lot of other constants which are part of the floating point arithmetic system. Then we are printing out those values. We just print out the floating point value 1.2. I'm doing here a division a divided by p, so we are dividing the value of 1.0 by the value of 5.0, and in the next line we are doing another division 1.0 divided by 3.0. Let's run that code with a cargo run command. As you can see in the output, we have here the range of our single precision floating point data type. We print out the value of 1.2, we print out the result of the division 0.2, and we also print out the result of the other division of 0.3 periodically. Besides the single precision floating point data type, Rust also provides you a double precision floating point data type called the F64 data type. As you can see, I'm defining here two variables with some floating point values, the variable c and d, and then in the first step we again print out the range of the double precision floating point data type by using the constants min and max of the F64 data type. Then I'm printing out the value 1.2 as a F64 data type. We print out the result of the division of 1.0 divided by 5.0. So let's run that code again, and as you can see, in the first step we have here the range of the F64 data type, which is very large, as you can see. Then we have that value of 1.2, which we have here, and the result of our division is again 0.2. In addition, Rust also provides some special values when you are working with floating point data types. We have, for example, the so-called infinite value. So when you are doing, for example, a division by 0 with floating point values, the result is always an infinite value, which you see here also in the output on the console. And there's also another special value called not a number. It's just an invalid number in the floating point system. For example, when you take the square root of the value -1, it produces as a result not a number that you can see here. So those are special values within the floating point system, which are also of course supported by Rust. Another very important data type that Rust provides you is the so-called character data type, which just represents a single character value, and that character value is stored internally in the Unicode format. As you can see, I'm defining here a single character value like the literal S, and I'm defining here some additional character values with some emojis, which are again stored internally as Unicode values. We define here a cat emoji and some emojis around triathlon, so swimming, biking and running, and then we do again a few print line macro calls to print out those character values. So let's run that code. And as you can see, we have here our nice cat, and as we know, a triathlon consists of swimming, biking and running. The last data type that I want to discuss today is the boolean data type, which just has two possible values, a value of 2 and a value of false. The value 2 is internally represented as a value of 1, and the value of false is represented internally as a value of 0. As you can see, I'm defining here a few variables. The variable p1 has a value of 2. The variable p2 has a value of false, and the variable p3 is just a negation of p2, so it has a value of 2. And then we are printing out those boolean values again with the print line macro. So let's run that code again, and as you can see, we have here our booleans printed out. p1 is true, p2 is false, and again p3 is 2. When we talk in an upcoming Rust Quickie about if statements and so on, we will come back to those boolean values because we need them here when we are defining conditions. So thanks for watching my Rust Quickie today. In my next Rust Quickie, I will talk about variable and variable bindings in Rust, also a very interesting topic. So thanks for watching, stay tuned, and let's hear each other very soon the next time. Thank you.